is Denzel Tracy de la Cruz, and I'm from Biles JA, and we'll be talking about the word meaning in Chapter 11 of Psychology of Language. Have you ever wondered how we understand the words we hear or read every day? Words are more than just letter put together. They carry meaning, emotion, and ideas. But what exactly does meaning mean when it comes to words? In this video, we are going to explore the fascinating world of word meanings, how words convey ideas, and how meanings change depending on context, and why we understand word meaning is key to communication. So, let's dive in and discover the magic behind every word. So, let's talk about the background of chapter 11 of word meaning. First, we have the introduction. Second, classic approaches to semantics, semantic networks, semantic features, family resemblance models, combining concepts, figurative language, and the neuroscience of semantics, connectionist approaches to semantics, and for the last is summary. So, let's talk about the introduction for semantics. Semantics is the study of meaning in language, focusing on how words we convey information. And understanding word meaning is crucial for effective communication, reading comprehension, and language learning. This chapter covers various theories and models about how word meanings are represented and processed. And for the first topic, which is the classic approaches to semantics, classic semantics view meanings as a set of necessary and sufficient conditions defining a word. For example, the word bachelor can be defined as an unmarried adult male. This approach often uses dictionary-like definition and clear-cut categories. However, it struggles with words that have multiple or flexible meanings or are context dependent. And let's talk about the semantic networks. Semantic networks organize meanings as nodes linked by relationships. Example, the concept bird might be linked to features like has wings, can fly, and has feathers. Links show relations like and is. A robin is a bird, part of. Wing is a part of a bird, or associated with. These networks help explain how we retrieve related concepts quickly in our minds. For example, hearing dog might activate related nodes like cat, pet, or animal. And for the semantic features, words are broken down into basic semantic features or components to explain their meanings precisely. An example, the word man might include male, adult, and human. This helps differentiate similar words like man versus boy, where adult is absent. Challenges arise because some words are vague or have fuzzy boundaries. Example, the difference between cup and mug can be subtle and context dependent.
Family resemblance models. Not all concepts have a strict definition. Some categories are fuzzy and overlap through family resemblance. Ludwig Wittgenstein introduced this idea, showing categories like games have no essential feature common to all but share overlapping similarities. Like, for example, chess, soccer, and tag are all games, but each is quite different. Family resemblance allows flexibility in category membership, reflecting real world usage better than strict definitions. Next, combining concepts. Meaning extend beyond individual words. Combining words create new meanings. Logical compositionality means understanding a phrase depends on combining the meanings of its words words systematically. For example, red apple combines the color red and the concept apple to specify a subject of apples. Exceptions include idiomatic expression like kick the bucket, whose meaning to die isn't deduced just from the words. Next, figurative language. Figurative language involves metaphors, similes, idioms, and other non-literal uses of words. It enriches communication with creativity and expressiveness. Like for example of metaphor, time is money conveys that the time is valuable, even though time isn't literally money. Next, example of idiom. Break the ice means to initiate social interaction, not literally breaking the ice. Figurative meanings rely heavily on the context and shared knowledge. Next, the neuroscience of semantics. Neuroscience explores where and how the brain processes word meaning. Brain imaging shows semantic processing activates areas in the temporal lobes, especially the left hemisphere. Different types of concepts, faces, tools, and animals can activate different brain regions, indicating an specialized processing. Understanding this brain mechanism helps explain language disorders such as aphasia, where the meaning comprehension is impaired. Next, connectionist approaches to semantics. Connectionist models simulate word meaning using artificial neural networks. These networks consist of nodes connected with weighted links that adjust through learning, mimicking neural processes in the brain. Meaning emerge from patterns of activation over many nodes rather than fixed features or definitions. Connectionist models can handle ambiguity, gradual learning, and context effects. Like, for example, a model trained on many examples might learn that bank usually relates to finance but can also connect to rivers. And last, word meaning is complex and has been studied through various lenses, from rigid classic definitions to flexible family resemblanceless semantic networks and features show the structure of meaning, while figurative language illustrates creative, non-literal uses. Neuroscience and connectionist models link linguistic theories to brain functions, reflecting how humans process semantics in real time. Together, these approaches offer a multi-dimensional understanding of how language conveys meaning.
As we conclude this exploration of word meaning, it's clear that semantics is a rich and multifaceted field. We began by looking at classic approaches which provide foundational but sometimes rigid ways of defining meaning. Then, we saw how semantic networks and features offers ways to organize and break down concepts that mirror human cognition more closely. We are also explored the family resemblance model, which captures the flexible overlapping nature of many categories in language. Moving beyond strict definitions, combining concepts showed us how meaning isn't just about individual words but how they interact to create new meanings. Sometimes straightforward, sometimes idiomatic or figurative. Figurative language highlighted the creativity and expressiveness of human communication, demonstrating that meaning often stretches beyond literal interpretation. Bridging language and the brain, the neuroscience of semantics give us insights into how meaning is processed biologically, with specialized brain areas supporting this complex task. Finally, connectionist models demonstrated a modern computational approach, modeling how patterns of neural activity might encode word meanings in a dynamic and adaptable way. Together, these perspectives deepen us understanding of how human grasp and communicate meaning in language, a cognitive masterpiece that blends structure, context, creativity, and biology. Thank you for your attention, and I look forward to any questions or thoughts you might have. Thank you.